This lesson is on topic 1.1, or measurements in physics. All of the topics will have an objectives page. Following the objectives page, there are understandings. These are the understandings associated with topic 1.1. There are understandings associated with each of the topics, and what they define are what you are expected to know. There are also applications and skills listed on each page about how you will use those understandings that IB requires of you. For this unit, what we're going to be talking about are a lot of review activities. Okay, we should already be familiar with the SI units, or the metric system, scientific notation, significant figures. Some things that might be new are orders of magnitude and estimation. Okay, so we will be practicing those skills in class. First off, the Système International des Unités is the international organization that defines standard units. We generally refer to it as the SI system, or just the metric system. Why do we have this system? This metric system allows us to communicate internationally with other scientists so that we're all on the same page. When we are not on the same page, lots of confusion can result, and this confusion can result in very expensive errors or even fatalities. There have been examples of satellites that have crashed or been lost in space because of a miscommunication of units. First off, there are 7 fundamental units associated with the Système International. 3 of those units we used lots of last year. Those 3 are mass, distance, and time. Mass is special in that it's the only unit where we keep the metric prefix. Okay, the standard unit for that is the kilogram. Always double check your units. Make sure it's converted into the fundamental or the standard units. Distance is measured in meter and time in seconds. You must remember all 7 of these, or at least these 6. Okay, there are 4 others: ampere, which we covered last year; temperature, which you're familiar with, measured in Kelvin; and count, which is mole, which you covered in chemistry. The one that you really don't need to know is the candela. Okay, that's one of the things that the IB says you don't really need to know. However, memorize these 7: mass, distance, time, current, temperature, count, and luminosity. Or in other words, kilograms, meters, seconds, amperes, Kelvin, mole. You will be asked questions on these by the IB organization, and in particular, the one that trips people up is ampere. But just to repeat, candela is not a required SI unit for this course. Every single other unit that we encounter is derived from those 7, some combination of those 7. For example, let's look at these 4 units that we saw last year: the Newton, velocity, coulombs, joules. Okay, Newton we derive from the net force equals mass times acceleration. Mass is just kilograms. Acceleration is meters per second squared. I want to point out to you the notation that the IB uses. Instead of using a fractional symbol, it expresses it as negative exponents. So you will see the seconds to the -2 in this case. Velocity, which is change in distance over change in time, or meters per second. In IB notations, meters times seconds to the -1. Coulomb, this is why amperes trips up people the most. Current is defined as charge over time. So 1 coulomb, if I reorganize that equation, becomes 1 ampere second. Joule, if you remember the formula from last year, work is equal to force times distance times the cosine of the angle between force and distance. And in this case, 1 joule is equal to 1 Newton meter, but Newton is also not a basic unit, so we convert that and it becomes 1 kilogram meter squared per second squared. And that brings me to the various SI prefixes. It's important to memorize these prefixes. Yes, they are given in the data book, but if you can memorize them, it allows you to convert them that much faster. We use them a lot, and I recommend that you memorize them. At least memorize nano to giga. Okay, nano is times 10 to the minus 9. Micro, that funny little U with the tail in front, it's actually the Greek letter mu, is times 10 to the minus 6. Milli, 10 to the minus 3. Centi we use a lot, especially in terms of centimeters, is times 10 to the minus 2. Kilo is times 10 to the positive 3. Mega times 10 to the 6. And giga times 10 to the 9th. The reason it's so important to memorize these is you should be able to mentally convert these prefixes into powers of 10, because that's the quickest way to automatically use that number in your calculator. Instead of saying nanometers, you would simply change the nano times 10 to the minus 9. So 520 nanometers becomes 520 times 10 to the minus 9 meters. And that's the easiest way to convert from the prefixes to the base unit. The only one you have to watch out for again is kilogram, because that one represents 1,000 grams, but that is the base unit. You need to convert all of your masses to kilograms. And just as a warning, I know a lot of you use that caret button on your calculator. I highly recommend not using that button. That button results in lots of errors that I see on people's tests when I grade them, and you really need to be careful in your use of parentheses. Instead, your calculator should have an EE button, which is exponential notation button, and that's a lot safer to use than using the caret button. We'll talk about that more in class. And that brings me to scientific notation. We use scientific notation to clearly describe a number without having to count zeros. For example, the speed of light is given as 299,792,458 meters per second. I can't even figure out, especially since I don't have commas, what number that is without reading it really slowly. And if I do that, it becomes 299,792,458 meters per second. It's a lot easier if I express that in scientific notation as 2.998 times 10 to the 8th meters per second. Or what I'll usually express it as is 3.0 times 10 to the 8th. It's really, really close to 3.0. I will also express it in E notation, which instead of saying times 10 to the 8th, I'll simply say E8. So 2.998 E8 is the same number as 2.998 times 10 to the 8th meters per second. That 8 is important because that 8 represents the order of magnitude, or basically the power of 10 for that number. So in the example for the speed of light, the order of magnitude is 8, and we'll talk about that a little bit later in this presentation. It's also useful a lot of times to talk in terms of engineering notation. It's similar to scientific notation, but all the powers of 10 come in multiples of 3 based on those metric prefixes. So, for example, again, using the speed of light, I could express 299,792,458 meters per second as 299.8 times 10 to the 6 meters per second. You can kind of look at it and say, well, it's 299.8 megameters per second if you wanted to. Okay, so you do have to be a little cognizant of that fact, and it helps if you are able to use those numbers. I will be using multiple prefixes and multiple notations, and you need to be able to read them in whatever form it comes to you as. You have to be careful on the order of magnitude because that only applies to scientific notation. I cannot say the order of magnitude for the speed of light is 6. Okay. So, significant figures we've been working with for a long time. We should be fairly familiar with them. Fairly comfortable, okay? When multiplying or dividing, we just round to the fewest significant digits, remembering that leading zeros are not significant, trailing zeros are significant. When I add numbers, I have to round to the nearest significant tenth place. So for example, I have 2.341 and I'm adding that to 14 meters. Well, if I think about it, that 341 millimeters, the other measurements, the closest I get is 14 meters. Okay, the millimeters almost are irrelevant. So that's why we round to the most significant tenths place. In this case, it's the unit place. Okay, it's the unit in the 14. So therefore, the 16.341 gets rounded off to simply 16 meters. Okay. Also, don't round intermediate calculations. Store them on your calculator or record them to 5 digits. Don't round intermediate calculations. If you are really bad at significant figures or you keep messing that up, the easiest thing to do, in my opinion, is to simply focus and remember to express everything to 3 significant digits. Set your calculator to 3 digits if you want. Okay, but don't ever write every single digit unless it's an intermediate calculation. It's not important. All those digits all the way down there, just get rid of them. Another part of this unit is estimation. And the more you know various numbers or can estimate things, the better off you're going to be on this area. So pay attention to the various numbers and get a sense for the order of magnitude for some of these numbers. Okay, for the example, a mass of 1 apple. Okay, when you think about it, you might have to do some conversions here, like how many apples do you get in a pound? Okay, maybe 2 apples a pound. Well, how many pounds are there in a kilogram? You may need to do some conversion. But a small apple is about 1/10 of a kilogram. The mass of the Earth is 6 times 10 to the 24th kilogram. The diameter of an atom is basically 1 angstrom. If you know what that is, it's 1 times 10 to the minus 10 meters. The diameter of the universe, when we get to the astro unit, assuming we do that, the diameter of the universe is roughly on the order of 27 meters. Okay, I mean, an order of magnitude of 27 meters. Okay, right now we're talking about 8.8 times 10 to the 26 meters. It is constantly expanding, so it changes over time, but that's our best estimate at this point. So the reason we talk about order of magnitude is because a lot of times we're just talking about rough estimates in physics. You know, does it make sense? Does it not make sense? If you're orders of magnitude off, then your estimation's not really good. If you're plus or minus 1, that's a pretty good order of magnitude. Okay, you're within 10% of the right, number. Okay, so a lot of times we simply talk about the order of magnitude as a means of estimating numbers. Okay, it's a very high level estimate, and sometimes it might make sense to round the number up to get you to that order of magnitude. Kind of have to use your best judgment here. Finally, the last thing we talk about is dimensional analysis, because a lot of times when you're stuck, just working with the units can really help you. Okay, for instance, if you can't remember a formula or it's a formula you have to derive, work with the units. Okay, for example, I have the formula distance is equal to acceleration times time. Well, we know that acceleration has units of meters per second squared and time has units of seconds. If I just multiply those units out, meters per second squared times seconds, that gives me meters per second. That's not a distance unit. Distances will have to just be meters. Somehow my formula is wrong. And it is wrong because distance should have been 1/2 at squared, or velocity is equal to acceleration times time. But so this is one way you can figure things out without having to actually come up with the formula, or helps you to derive the formula. Useful when you're desperate, and it's useful for getting a sense of how to approach it. So dimensional analysis is a useful tool. Thank you.